Good afternoon, everyone. My name is John Einkoff. I'm a Senior Product Manager at AWS. This session is orchestrating big data integration and analytics with AWS Data Pipeline. I'm going to talk for a few minutes to give you an overview of the data pipeline service. And then I'm joined by two gentlemen from Swipely that are going to talk to us about how Swipely is using data pipeline for their big data workflows. I'm going to try to keep my comments to a minimum because they have a lot of great material. They have some tips and best practices that they're going to share with you. So first, I want to talk a little bit about what are the challenges in dealing with data, and especially big data. So one of the challenges is that data is stored in different formats and different locations. This makes it very difficult to integrate. So I'm curious, with a show of hands, could you raise your hand if you currently have data stored in Amazon S3? Everybody, OK. How about, how many of you guys are using Redshift today? OK, maybe half, a little more than half. How many of you are using Amazon EMR? OK, also maybe about half. RDS? OK, about half. So you got, and I noticed that many of you guys raised your hand for multiple of these data stores. So you probably agree that it's difficult to integrate data and process data when it's stored in many different places in different formats. You may, and you probably also have data on-premise in an Oracle data warehouse, in flat files, in kind of any number of other data stores. And so let's say you have data, some of your data is on the cloud in AWS, and some of your other data is on-premise. It's especially difficult to move data back and forth and to integrate it into your data workflow. So a second challenge is when you're trying to process data, when you're trying to do analytics, you need to manage dependencies. So you may have a data workflow that you do not want to run if the input data for that process is not available. You may have a workflow that requires that step 1 succeed before you proceed to step 2. You may have a workflow that you only want to run once a day, once a month, a certain time of the day. But so you have all of these conditions, and you want to make your pipeline or your workflow contingent on certain of those conditions. A third issue, a third challenge that you need to deal with in working with data is that things go wrong. There can be quality issues in the data. There can be human errors. There can be any number of things that can go wrong, and you need to be able to deal with those exceptions. For example, do you want to retry in the case of an error or an exception? What do you want to do if one step in your workflow is taking much longer than it was supposed to? That could be a problem. It could be OK. Maybe you're just processing more data than usual, that particular execution of the pipeline. Do you want to be notified if something goes wrong? These are all things that you need to deal with whenever you're constructing big data workflows. So a fourth challenge is that there are commercial tools on the market that attempt to do data integration, data analytics. The challenge is that many of them are not really a great fit for the kinds of data and the kinds of things that we're trying to do today with data. Many of them come with very expensive upfront licenses. Many of them are designed to scale up onto bigger machines rather than scale out. Some of them do not support scheduling. Many of them are not designed for the cloud. They have kind of added on cloud services as kind of a bolt-on rather than a natively supported data store. And an example of that is some of the tools on the market today don't support really important data stores like Amazon DynamoDB. So that is why a year ago at reInvent last year, we announced AWS Data Pipeline. We are trying to create a service that will address many of the challenges that we just talked about. So you may have seen this slide before. This is a very simple abstraction of a pipeline. So one pipeline might look something like this. You have an input data node. That could be something like an S3 bucket. You might attach a precondition to that data node. So the precondition might look something like the S3 bucket must have objects in it. The next step in the pipeline is an activity. So an activity is just something that you're going to do to that data. It could be something like a copy. It could be something like a Hive script. And attached to that activity, you may want to have certain failure notifications, delay notifications, to let you know when something has gone wrong. And then optionally, you might have an output data node. So if the input data node was an S3 bucket and the activity is something like a Hive script, the output data node might be DynamoDB, or it might be something like another S3 bucket. So let's talk a little bit in the next couple of slides about what does data pipeline do, where does it really shine, and then we'll also talk a little bit about some of the areas where the product is continuing to evolve. So one of the things that it really shines at is if you have data stored in multiple different data stores on AWS. So we talked earlier about Redshift, S3, EMR, Amazon RDS, DynamoDB. These are some of the data stores that are natively integrated today. As AWS adds more data stores, you can expect that the number of data stores that are supported by Data Pipeline will continue to grow as well. Some of the activities that you can do on those data stores include things like copy, MapReduce job, Hive job, Pig job, SQL activity, arbitrary shell command. That last one is especially important because it's very flexible. You can do a lot of things through a shell command, and that's one of the most popular things that our customers use today. So we talked earlier about it's difficult when you have data on-premise as well as in the cloud. So another area where Data Pipeline really shines is if you have data on-premise and in the cloud, and you need to orchestrate periodic movement from on-premise onto the cloud, from the cloud back onto on-premise. We see many of our customers using this, and this is one of the areas where Data Pipeline, again, really shines. Dependencies, so preconditions is a very important part of Data Pipeline. It's relatively simple to set up a precondition. So some of the preconditions that are supported today are on this slide. It includes things like DynamoDB table exist. Does DynamoDB table have data? Does the S3 key exist? Is this S3 prefix empty or not? Has a custom Linux shell command succeeded or failed? So you can attach these preconditions to objects in your pipeline to make sure that certain preconditions are met. We talked earlier about alerting and exception handling. So this is the scenario where you need to deal with things that go wrong. So within Data Pipeline, you can set up notification on failure, on success, on delay. So on delay might look something like this. Let's say you have a Hive script and you expect that it's going to take about 30 minutes. If it starts taking an hour, maybe an hour and a half, you want to be notified that something is potentially going wrong. There are automatic retries that are built in. I believe that automatically we configure 3 retries. You can configure that to be less or more. You want to, just as a quick tip, you may want to be careful about configuring more retries than the default because you are consuming resources. These activities may be running on an EMR cluster. They may be running on EC2 nodes. If you were to set your retry to 10 and there was legitimately a problem with the data, you may not want to actually retry 10 times. You might want to be notified so that you can figure out what the issue is and correct it. Scheduling. You can set up your pipeline to run every hour, every week, every month. The highest frequency that you can set up is every 15 minutes. Backfill is, moving down to the second bullet, backfill is an interesting feature on Data Pipeline. The idea there is you can start your pipeline on a time and date in the past. So let's say today is November 14th. I can start my pipeline January 1st. And Data Pipeline will spawn multiple instances of that pipeline, and it will execute them in parallel to get you from January 1st all the way to today. That it's very useful if you are just getting started with Data Pipeline and you need to run it on historical dates. We talked earlier about the need to be scalable. So rather than scale up onto a larger machine, Data Pipeline takes a very different approach. It is sitting outside of the resources that are actually running the activities. So let's say your pipeline looks something like this. You have a web server on EC2. It's creating logs. You are copying those logs into S3 once a day. And then once a week, you want to run an EMR MapReduce job to come up with some sort of insight on those logs. Instead, the data is not actually flowing through Data Pipeline. It is flowing through EC2, S3, and EMR being EC2 underneath. The reason that is very important is that you could add multiple clusters, you could add multiple EC2 nodes, you could add an arbitrary number of data nodes and activities, and it will continue to scale. This is not true of some of the other alternatives that are on the market today, and it's one of the core things that we designed about Data Pipeline. One other point to keep in mind is that you can have a data pipeline in US East that is managing resources in other regions. So let's say you have data in Tokyo. You could be running a pipeline in US East that is orchestrating activities in Tokyo, in the Tokyo region. So an S3 bucket in Tokyo, EC2 instances in Tokyo. It kind of comes back to the original point, which is that data pipeline is designed to scale. We've done a number of things over the last 6 months or so to make it easier to get started with data pipeline. It is still less than a year old, so there's lots of things that we want to continue to do to make the product easier to use. Some of the things that we provide today are templates for common use cases. So for example, some of the templates that we provide is DynamoDB to S3 copy, S3 to DynamoDB, S3 to Redshift, Redshift back to S3. There's a number of these kind of common use cases that we have created a template for to make it easier to get started. There's a graphical interface, so you can certainly, you don't need to use the graphical interface, but if you're just getting started, it may be an easier path. Data pipeline natively understands CSV and TSV. And if you're dealing with EMR, if you're launching Hadoop and MapReduce jobs to analyze the data, data pipeline will automatically configure those clusters for you. It's one of the things that is a really nice feature about data pipeline, that you don't need to worry about some of the cluster configuration details of EMR. And lastly, it is very inexpensive. A simple pipeline, it very well will be free. So there's a number of preconditions and activities that you get for free because data pipeline is part of the free tier program. If you have a more complex pipeline and you have, say, 10 preconditions and activities, the pricing is all right in front of you. So depending on the frequency that you're running at, it could be 60 cents per activity or precondition, or it could be $1 if you're running at a higher frequency. But it's very simple, it's very straightforward, and as you can tell, this is not going to cost you an arm and a leg, unlike some of the alternative solutions that are on the market today. So let's just, I have 2 more slides. I just want to quickly walk through an ETL example. So in this example, what we're trying to do is bring together log data in S3 with customer data in RDS. We want to process that in Hive and load it into Redshift so that analysts could use a tool like MicroStrategy or Tableau to query against it. So, and I apologize that the icons are a little bit small, so it may be difficult to read this. But in the bottom left here, we have 2 data nodes. On the left, we have S3, which is just unformatted logs. And right next to it on the right, we have RDS, and that is containing customer dimension data. The little gear icon is an EMR Hive job that is going to process that data. And then the next gear icon is a Redshift copy. So we're going to be copying the data into a Redshift impressions table. And then we're going to run another SQL activity to put it into a final table, and that's the table that we're going to use in our BI tool. So to take it one step further, what we can do with this pipeline is we can run it on a schedule. So we can run it hourly, weekly, with whatever frequency you want, as long as it's something more than 15 minutes. We could attach a precondition so that Hive, for example, depends on the data being available in S3. We can set up notifications with SNS so that if something goes wrong, say on the Hive activity, you can get an SNS notification letting you know something has gone wrong so that you can inspect it. And lastly, if we want to, we could change some of the default retry logic on, say, the Hive query. Maybe we only want to retry twice rather than 3 times. So hopefully this gives you an idea of, for a very simple ETL scenario, what a pipeline would look like. What I'm very excited to do now is invite Anthony-Accardi up from Swipely, who's going to talk to us about a much more interesting, more detailed scenario of how Swipely is using data pipeline. Thank you.
There's a perception in our industry that we can't benefit from big data tools unless we have so much data that there's no other choice. We hear questions like, do you have a big data problem? We hear assertions like, don't use Hadoop, you don't have enough data. And perhaps most concerning, we see people who are reluctant to take on new data because they want to hold on to their old way of doing things. So what if the problem isn't the data, but rather that the tools are cumbersome and hard to use? What if someone would make the big data tools that are easy to use and painless? There are 3 ways that we can all benefit from big data tools right now. The first is we can build novel features using batch architecture. And I'm not talking about just taking some analytics and loading it into Redshift so that the back office can make use of it. I'm talking about real features that customers pay money for. The second thing we can do is decrease development time. Once you get that new feature out there, it's relatively easy to incorporate new data into it into the future. But there's always a backfill challenge. You always have a lot of data that's already out there that your users have already built up. And the question usually comes up, how can you build and incorporate that data into your new feature? And big data tools can make that easy as well. And finally, the third thing we get is that we get a very simplified operational story. With big data tools, we can scale more easily, and we can also have a clearer provisioning story and cost structure. So Swipely resonates very deeply with these three needs. Swipely is the simple way for local merchants to process payments, understand customers, and grow revenue. So it is core to our business to use big data, particularly around payments data, to make that actionable for our merchants, our paying customers. Swipely is also an agile development company. We deploy to production many times a day, and we rapidly iterate on our product. So it's very important for us to also keep development time very short. And finally, Swipely is a startup. We don't have many resources. We have 2 operations guys on our team. And so it's important to us to keep the operational side very simple and very easy to maintain. So we use Data Pipeline to meet these 3 needs. Now I'm going to first walk through the types of product features we build with batch analytics. And the feature I'm going to talk about is a fast dynamic report that involves mashing up data. Now I want you to pretend for a moment that you're a local merchant. Say you own a restaurant, and you just launched a marketing campaign during Mother's Day. And people came in, ordered stuff. You want to now know how effective your campaign was. You can go to Swipely. We have this tool called Campaign Insights. You can enter your dates of Mother's Day, May 10th through May 12th, specify what data you might want to mash up with it, and click this button. And then boom, what comes back, here's a portion of the report that comes back. There's a lot of information here, right? There's sales by day. So at the top level, you can figure out how much money came in over the weekend and Mother's Day, how that compares to your average Friday, Saturday, Sunday. You can see who your best customers are coming in, who came in that weekend. You can also get a read on what your acquisition and retention is, how many new people came in, how many people came back that you've seen before. Now, there's no rocket science in building this report. The new thing, the novel part of this feature, is that you can put any date range in there and click the button. And as quickly as it takes me to advance the slide, the report like this comes up. Well, how do we do that? Well, we pre-compute as much as we possibly can ahead of time. We start with our raw data, our foundational data, our facts, our swipes, our transactions on credit cards. And we run MapReduce jobs using Data Pipeline every night to build structured database tables to make this query very, very fast. Okay? And so this is a data flow diagram. You can see we start on the left-hand side with facts, like these transactions, these credit card transactions. We run a MapReduce job to create intermediate and group basically by day, your sales by day report. And then we have another step where we insert that into a database so it can be quickly indexed and queried. Now it takes instances to move this data around and process it. We need an EMR cluster. We need instances to do that inserting, to do that post-processing. And the whole thing's coordinated with AWS Data Pipeline. I'm going to run through an example now. So if you look at the top part, if you look at the sales by day, in order to compute those numbers, we take data that looks like transactions. So someone went to the cafe on March 30th, and using their credit card ending in number 4980 spent $72. That's the sort of raw data, the facts that we start with. We run a simple MapReduce job to group all those transactions by the merchant, the cafe, and by the date to conclude that $4,030 were spent on May 10th. And the point is, on the right-hand side, that can be very indexed. Now we just return with a simple index query, 3 rows, to be able to compute the report. Now, this is very simple. We don't need Amazon Data Pipeline to manage this one MapReduce job. The beauty is Amazon Data Pipeline makes much more complicated flows as easy as managing this simple one. So if you take a look at the customer visits, that's a little bit more interesting, right? Because now we have to know for each visit, for each credit card transaction, have we seen that person before or not, right? And we can accomplish that by cascading 2 MapReduce jobs. First, we go from transactions to visits and determine whether or not we've seen that transaction before. You have it's either new or it isn't. And then there's more of a standard aggregation MapReduce job that groups by merchant and by day. So we get to the number of new people. So a little bit more complex. And if you look at this best customers portion of the report, that's even more complex because now we have names. We have people's personal information associated with these credit card transactions. We have Mary instead of a credit card number. That comes from a new fundamental data source, a new type of fact called card opt-in, where Mary has basically registered her credit card and associated her personal information with that card. So we use a Hive activity to join the visits that we spoke about before with this new input table to compute what we call on the right-hand side analytics documents that can be very efficiently queried to build the report that you see. Now, we've wound up with a much more complicated pipeline, a more complicated MapReduce flow. Data Pipeline makes it easy to manage this by specifying everything declaratively through dependencies. So what I want to do now is hand things over to Bright Fulton. He's our lead operations engineer. And he's going to walk you guys through how we actually do that with Data Pipeline. Thanks.
All right. So John talked a lot about the different data stores and the different type of nodes that you can put in a data pipeline. And Anthony talked a lot about the way you build up complex pipelines to do novel analytics. I just want to bring it down to a very simple level. We're going to take a piece of a pipeline. This is a sales by day aggregation that goes through MapReduce. And just want to run through it in order to show you what our engineers do on a sort of day-to-day basis as they're developing and looking at pipelines. So we edit the JSON directly. That there are other options, but this is what we do. And so if you think about the slide that Anthony left you with, where we have our fact store over on the left, and it transitions through an EMR job into an intermediate S3 bucket, and then gets inserted through a copy activity into an RDS instance. That flow goes from facts that are coming in without structure, and then they get mapped and reduced. And so this first set of nodes here, the S3 transactions, that's the stuff on the left. This S3 sales by day, this is a node that's declaratively describing the intermediate bucket that the stuff gets put in. And then finally, the third data node that we have in that graph is the stuff on the right. This is the RDS node. This is a MySQL instance where our reduced values end up getting inserted. You can see the insert statement there. Cool. So the next level up in that diagram was the resources that it runs on. And there were 2, if you recall. One was the EMR cluster, and then the other was the EC2 resource, which actually did the insertion. And then, sorry, that's the EMR cluster there, and then that's the EC2 resource that it runs on. And there are some other nodes that are kind of boilerplate, but you can see, you get the sense here, right? We're dealing with a few pages of JSON, and this declaratively describes that whole data flow from left to right. Cool. So another way that we can kind of get confirmation that what we're doing makes sense is by visualizing the pipeline itself. So one of our engineers, Matt Galuli, wrote a tool called Pipely. It's open source, swipely/Pipely on GitHub. And you can use it to visualize the nodes that you author. So let me just give you a sense for that. So we'll just do bundle exec Pipely. So it takes as input the JSON file and writes as output a PNG that you can just open up. OK, cool. So what we can see here is that we have our transactions input, gets processed by the EMR activity. Output of that is the S3 data node. Then it goes through the copy activity and into the MySQL node. This is useful if you misauthor your data pipeline. You could end up with a sort of orphaned node or subgraph that you would want to correct. So that's part of the flow. And then I just want to show you a sort of time-compressed video of deploying and watching a pipeline get run through, just to give you a sense for how that looks. Again, this is a very small example. OK. So the first thing that we do is we're just deploying from the command line, like anything else that we do. I don't know if you noticed, but we're using our FOG credential here. One of our engineers, Keith Barrett, added data pipeline support to FOG. So I don't know how many Ruby guys are here, but FOG has good data pipeline support. You definitely use it. So it goes through some prep work in S3, uploads our mapper and reducer steps, and then ultimately puts the pipeline in. So here, if we visit the data pipeline console in Amazon console, we can see that our pipeline was created. Here are all the steps that we defined in that JSON file. And if you look through in the status column, you can see that some of them are in a creating state. Some of them are already finished. Those are the data nodes that already exist. And some of them are waiting for dependencies. If we go into the EMR console, the newly updated EMR console, very cool, we can see that one of those resources that Pipeline's orchestrating for us is a new cluster. So it's spun up a new cluster to process this EMR job. And we can see that the initial things that it's doing here are installing Pig and Hive and so forth on the cluster. So I just want to show you again here using Pipely. Instead of going at a static JSON file, we're going to connect directly to the data pipeline API and get status of our running pipeline. We can open that up. And this time we see that we have some colored nodes. So the ones that are finished are in blue. Here's one that's waiting on a dependency, and then downstream ones. So that's a cool way to get feedback as it's running. Of course, you can also look at it in the Amazon console. Here we are back in the EMR console, and you can see that we have some pending jobs with tasks, mapping and reducing tasks. And they're all in a pending state, so they haven't begun yet, right? They're getting ready to work. If a little time goes by, in this case, not much time, this was a very small job, we see that the map ones get turned into running, and the reduce ones, because they come after, are still going to be pending. And it looks like one map was already completed. And then we can kind of keep bouncing back and forth depending on what you're trying to do. I just want to show that Pipely can also sort of update as that progress goes through on the pipeline. So here we go, opening up in Pipely again. Now we can see that our EMR job is in a running state, it's green, and downstream stuff is still waiting. Cool. So when that is completed, right, all of our mapping and reducing steps have been completed, then we're going to see that we can get one more graph out of it, and it'll move on, show the progress past the node. And this is just a kind of a flow, a debugging flow or a development flow. This isn't what we don't like watch our production stuff go through. All right, and then here we see we're back in the data pipeline console, back out of EMR, which is completed. And you can see that now Pipeline is orchestrating the shutdown of all of our resources, which is very cool because we only paid for exactly the amount of time that we used them for. And then just to confirm for ourselves, we can see that our graph viz thing goes all green at the end, or all blue. Cool, so everything's done. Of course, we just want to show that the result actually ended up in MySQL. You can see that we have a very simple table here that just has a primary key, which is the store day. That's the mapped part, right? Like, so we mapped all of our card transactions into a key of store and day. And then we reduced them just by summing aggregation into the total sales for the day. And then we can use that to generate reports, like Anthony was mentioning, where we just have the sales by day for a particular merchant. So hopefully that gives you a sense of a simplified flow and what it actually looks like when it runs. Thanks.
So that's how we build new features with Data Pipeline. Now, it's not enough to build new features. We want to build them quickly. And that brings us to the backfilling point, to the backfilling issue. So remember, we push the feature out. It's easy to get the data and incorporate the ones that come in the future. But the challenge is, how do you process all the historical data you have to bring it into your feature? Now, what we used to do is there was always a migration we would need to run. It was, despite our best efforts, it was always a one-off sort of thing. The engineer who's responsible for the feature had to wrangle the resources and figure out, well, how much computation would he really need? We'd have to coordinate with operations. Testing always came up. How do we know it's going to work and not going to break on production? It was always difficult to get the full data set on production to test. So we were concerned about, well, maybe there's some data in production that we're not seeing in our test set that's going to make it fall over. And it was, in general, just a hassle. We don't do any of that anymore. With Data Pipeline, instead of that complicated backfilling process, we basically rebuild our analytics documents regularly, daily, okay? And that allows us to rapidly iterate our product, and we do it with an agile process. So this is a block diagram description of the architecture, and you can see our facts, like the transitions in the card opt-in that we talked about in the example, go in directly to this fact store that we store on S3. And then Data Pipeline, we schedule to run daily to crunch that and mash up all that data to produce our analytics documents, and that's what the web tier hits. Now, as a side note, I don't want any of you to leave thinking that this architecture only lets you build features that change once a day. That is the example that I gave you, the campaign insights. But we also use this architecture, this batch processing architecture, for more real-time features. And we do it by adding another database, a recent activity database. And the idea is that the transactions, and the card opt-in data don't just go into the fact store, but we also shove them into the recent activity database so that when a query is made, the analytics documents take us up to this morning, and then all the rest of the data from this morning to now is in the recent activity, and they get merged together very quickly when the web request gets served. So let me show you what we can do with this. Here's the campaign sales by day feature. And imagine for a moment that we want to compute these numbers differently. Maybe we changed our mind. We want to compute gross sales instead of net sales. Or maybe there was a bug. Maybe we computed it wrong in some cases, in all cases. The cool thing is that we don't actually care whether it's a bug or a new feature or a change in a feature. Because when we rebuild the analytics documents every night, it's relatively simple in this example to change the logic, to fix the bug, to change the accounting rules. That's a simple code change. And now we know by the next morning, all the data will be consistent with it. Now, of course, if it's a egregious bug, if it's a really bad bug, we won't wait till next morning. We'll just kick the pipeline off immediately as soon as we fix it. So we have that degree of flexibility too. This strategy also works with much more complicated features if we iteratively build out a product. So for example, if you look at our best customers report, you might reasonably find lots of different ways that you define what your best customers are. A simple definition for a campaign spanning a weekend is just how much money they spend over that weekend. But you can get more sophisticated, get at lifetime value. You can look at what they're doing online, other ways that they're interacting with the merchant. It can get more sophisticated over time. So what this batch architecture allows us to do is iteratively build out those features, make the code changes, and then see the updates the next day. It's very powerful. Now let me talk about how we actually implement this in Data Pipeline, because you see, we don't actually get an agile development process for free. Amazon gives us a lot of options. There's a lot of functionality and features in Data Pipeline, and we've learned the hard way how to best use those features to craft an agile process. So I want to share with you guys some of the things we learned. And it really falls into 4 different pieces of advice. The first is, you saw there are different ways you can interact with Data Pipeline. As John showed you, you can use the GUI. As Bright showed you, you can work directly with the JSON. We operate with the JSON, but a slight layer above. We wrap the JSON in our own code, and we'll tell you why in a moment. There's also a lot of options, a lot of different parameters you can specify in data pipeline nodes. There are different ways you might want to set those to reduce the variability that you're dealing with to make the failure mode simpler. Amazon built quite a sophisticated logging mechanism for data pipeline, but in order to take use of that to make sure you diagnose the failures and tighten your development cycle quickly, you need to enable it and configure it properly. So speak about that. And finally, there are different ways you can automate some common tasks with data pipeline to ease your development burden. So this is another look at our JSON. This is the EMR activity node that Bright showed you. And you can see there's a description there to specify your input, your output, and also your mapper and your reducer. We're a Ruby on Rails shop, so you can see the Ruby files there. And the interesting thing here is that this is a template. We interpolate those variables, in this example, the data path and the code path. So we're programmatically generating the JSON. That gives us a lot of power to define these pipelines. There's a more subtle benefit too, though, which is by wrapping this in our own code, we now can leverage our existing code infrastructure, our existing practices. We undergo code review. We check everything into version control. We basically treat the pipeline code like any other piece of code in our system. And if we were to write this today, it would look more like this, where we're starting to define our own helper methods and functions to make it easier to just deal with the things that we care about in working with the pipeline. And we're actually moving in a direction right now of defining our own domain-specific language so that we can be more expressive and concise with what we're trying to do with the pipeline. Let me talk about reducing variability. There's a few things we learned in terms of parameter settings. We haven't had much luck running pipelines on small instances, in particular MapReduce jobs, so we encourage everyone to maybe start with a large. You don't need super beefy instances. That's not the idea of horizontal scaling, but we haven't had luck with smalls. I also encourage folks to lock your versions. The Amazon Data Pipeline team makes a lot of updates. They're very active. And it's painful to learn about their updates when you realize that all your pipelines are broken because of a version dependency because you didn't lock your versions. So we learned that one the hard way. And finally, this might not be obvious, but we started out, we were wondering how to best structure security groups with pipelines. And we started out adding new security groups for new pipeline resources and new pipelines. And that became very cumbersome. What we do now is we statically define security groups by the databases, by the data that they need to access. And then when we define a new pipeline, we point to one of those predefined groups. That's been working a lot better for us. In order to diagnose failures, you're going to want to turn on logging. And what we do is very convenient is we namespace the logs so that for a particular environment, for a particular time that the pipeline runs, it winds up in a particular directory on S3. What that lets us do is when our developers run a pipeline, they know exactly where to find the logs for that particular run. It makes debugging much easier. And also, when we're developing, it's very useful to be able to log onto the instances directly when things go wrong. And so it's helpful. There's a key pair, an SSH key pair attribute you can set to allow you to do that and log on directly. And finally, there are a few things to automate. This is a very cool parameter, terminate after. It ensures that no matter what happens to your pipeline, it shuts down in that given amount of time and you're no longer paying money for it. You know, you might think you want your pipeline, all the resources to disappear as soon as the pipeline starts running. That's true when your pipeline is successful. But when your pipeline fails, particularly in development, you probably want some time to have engineer to be able to investigate the dead body and figure out what might went wrong, what might have gone wrong. And so something on the order of 6 hours has been working for us because it gives folks enough time to get around and uncover what happened, but ensures that we don't wind up paying for pipelines that we ran a long time ago. And this is a cool trick that you may have noticed in Bright's JSON, but we have a need to bootstrap our EC2 resources and pipelines. We basically set up various Ruby gems and whatnot that we need for processing. And what we do is we define a shell command activity node, and we make it a dependent of those resources. And all it does is reference the bootstrap script that we want those resources to load. And so Bright used that trick before, and we use it frequently in our more complicated pipelines. So no need to backfill your data using old techniques. We can rebuild the analytics documents daily. That helps us iterate quickly on our product. And we can also craft and use all the options and features that Amazon puts into their data pipeline to create an agile development flow. Now, we've built something. We've built it quickly. So even better than building it is being able to build it quickly. But better still is once we ship the feature, can we easily scale and maintain it? And with Amazon Data Pipeline, that lets us have a simple horizontal scaling story and a simple provisioning story. We aim to complete all of our pipelines in 50 minutes, and the cost structure is very attractive. We're able to store all of our data even with that constraint. This is the output of Pipely, the gem that we wrote. It's a more complicated pipeline than Bright showed you. This is one that we run in production. And the interesting feature about this pipeline is that all those unhappy grade nodes are waiting on one EMR activity. Now, that's a beautiful thing because MapReduce scales horizontally. So if all of your pipeline bottlenecks are EMR nodes, then you can conceivably, the first order, throw more resources at the problem, and then the entire running time of your pipeline goes down accordingly. So we make great use of that. We start by choosing the smallest capable on-demand instance type. Remember, no smalls, but we don't want big, beefy instances. We're not vertically scaling. We run a lot of pipelines on M1 largest. That gives us a fixed hourly cost, and we also don't pay for any idle time. We just pay for the resources that we use. Now, to first order, if things scale horizontally, then the cost of running one instance for 100 hours is the same as running 100 instances in one. So if the cost is the same, why not do it all in 1 hour? We pretty much do that, except there's a little bit of a fudge factor because there's about a 10-minute runtime variability, just instances starting up and whatnot. We don't want to get accidentally charged for 2 hours, so we shoot for 50 minutes. And just as example, this is it's a very small pipeline. There's only 50 gig of facts that we're processing, but it's a complex pipeline. It's on the order of the one I showed you a slide ago with Pipely. We can crunch that in 50 minutes using 40 instances under $10, so very cheap. And it's interesting to stop for a moment and think about the cost comparison there. You know, it's $10 versus what? Well, the obvious way to compare it is, well, what if I'm running 40 instances? What if I run that 40 instances throughout the entire day instead of just for that 1 hour? So that's a 24x cost savings. But if you just hypothetically put me in a position where Amazon Data Pipeline didn't exist, we wouldn't actually do that. It would be too expensive at scale, right? And so what's interesting there is it puts me in a position of, well, how much time can we get away with? And in production, maybe we'd be willing to run a pipeline over or a MapReduce process over the night and suffer maybe 6 hours runtime or whatnot. That gets interesting because then your developers get frustrated because they don't want to necessarily wait 6 hours to get a pipeline return. And so then what are the trade-offs there, right? You might want to give your developers more resources or find a way for them to test and develop with less data, and it gets into a trickier trade-off space. So I just want to call out the punchline here is that it's not a straight cost comparison for us. It's actually a scale, cost, and latency comparison. And we wind up in a pretty attractive place at 50 minutes and those cost numbers. Now, this is instance cost. We also should talk about data storage costs because at scale there's a lot of data involved. The good news there is it turns out to be relatively cheap because we can do a lot on S3. And most of our data are facts. In this example, we're only talking about 50 gig of facts. But you want to store all your facts. The facts are our primary data source from which everything else is generated. They're the crown jewels, if you will, the source of truth of everything. And the thing is, we can just use S3 for that because the only thing that consumes those facts are resources through Amazon Data Pipeline. We don't need them to be indexed. So we can have very cheap storage there, $5 a month for just this 50 gig set of facts. Now, your analytics documents are a different story. They need to be quickly indexed, so they need to go into a real database. So, but the benefit there is they're typically aggregated, so we're talking about less data. So in this pipeline, the 50 gig of facts translates to 20 gig of analytics docs, which is a bit more expensive, $250 a month, but that's mostly instance cost. Finally, there's all the data in between. There's a lot of intermediate data that's generated in these pipeline flows, and we retain them for diagnosis. In this case, this pipeline generates a little bit over a terabyte of data that we store all on S3, goes back 60 days. That's, to be honest, much more than we need. The point is, storage on S3 is relatively cheap, and we can afford to store most everything that we want to. So That's how we use Amazon Data Pipeline to have a simple horizontal scaling story, run all of our pipelines in 50 minutes, and store all of our data. The impact of AWS Data Pipeline cuts across product, development, and operations. We're able to build new things, build them quickly, and we're able to scale and maintain those features easily after we ship them. Now, we adopted Amazon Data Pipeline before we really needed to. We got ahead of our big data in that sense, and before our data grew to be unmanageable. And in hindsight, we're very glad we did that. We've talked about a few of the benefits here, but I have to tell you guys that the biggest benefit is that now when we look at a new data opportunity, instead of the feeling of dread that we used to get about how much effort it would take and pain it would take to handle that new data, we now have a feeling of excitement about what we can do with that data.